what I know is the mass is the measurement of the amount of the matter, means the
Good.
amount which is in the matter, and
Good.
the weight is the gravitational force on the object.
Good. Perfect. What about Ryan?
That's what I was gonna say.
Okay, they're same. Okay, that's a smart answer. Okay, okay. So I'm gonna first of all gonna start discussing on mass. We're gonna discuss the properties of mass and some examples on it and what are the SI units, some definitions over here. Then I'm gonna talk about the weight and its SI units and it what does it mean with some examples. And then we'll compare both of them. We're gonna derive a relation between mass and weight. And then we're gonna talk about some gravitational field strength, right? So because gravity is pretty important, right? In case of weight. So yeah. So let's start with the mass over here. So we basically कोई गया है basically someone went to let's imagine this is Ali. Ali went to a shop, ठीक है? And the shop is basically the milk shop, right? It says कि it is a milk shop. And I believe कि both almost all of you, ठीक है? Most of you, ठीक है? Not all of you would have said कि let's say you went to the shop and you said कि you want 1 kg of milk, right? So what do you mean by that? Are you meaning that you want 1 kilogram mass of milk or 1 kilogram weight of milk? What is scenario over here? Can you explain this? पहले बताएं किसने किया ये? कौन? Who is the person who basically has went to a milk shop in his in her in his
I have
child
done
has
this.
went to it. Dayan नहीं गया होगा. Bertha, what about you?
No, I haven't gone to a that's all.
ठीक है. So most of the people confuse.
Sir,
रयान गया है. Okay, जबरदस्त जबरदस्त. रैन गया है ठीक है सो मोस्ट ऑफ द पीपल से बेसिकली दे से कि weight is equivalent to mass right most of the people have an idea कि weight is equivalent to mass ठीक है and that is pretty wrong right so वो समझते हैं कि हम बोल रहे हैं कि 1 किलोग्राम is basically the weight of the milk which I'm ordering but actually they weight using a huge basically cup which basically measures the number of liters right that is amount of mass. See, this is a pretty common mistake which I have also gone through in my childhood, and I realized it when my sir basically spoke the truth, right? So, jaldi se let's skim the content for about, then we're gonna relate with some examples, right? So, the mass of an object is the measure of amount of what matter in the body, right? So, what is matter? Can you explain what is matter? This is turning into chemistry class. What is matter? Yes, anyone? What?
matter is anything that makes up a substance.
Yeah, ठीक है. Matter is basically the atoms in our body, right? The atoms in our body is basically matter, right? Which has mass, it occupies space, it has density, right? So it is just a measure of amount of matter in a body. Like imagine कि आपके पास you have 2 cubes in your let's say in your room. One cube is a red cube. Alhamdulillah, sorry. And it contains liquid, right? It contains liquid, right? And the other container, this is container A, and you have container B, which contains basically gas, right? So gas को हम ले लेते हैं कि it's sort of let's say these are atoms of the gas. So which container has the most amount of matter? Container A or container B? Yes. Let's say if I give you a value also, ski mass is let's say 4 kg and this mass of container B is 2 kg. So which one is has the most amount of matter over here?
Sir, A.
Container A obviously liquid dense भी ज़्यादा होता है ठीक है if you just see the properties of liquid and solid you will see in the next classes so you will see कि container A matter in container A is greater than matter in container B because उसकी mass ज़्यादा है right so amount of matter हमने measure की which give me basically this relation over here right so it can be stated that a mass is a measure of the quantity of matter in an object at rest relative to an observer, right? So what are they seeing over here? Okay, let's imagine if there is a person over here, Kashif. Okay, Kashif is a person standing over here, and let's say he's seeing this particular container A, which contains liquid, right? And let's imagine if we have observer number two, that is, let's say Ali again. Ali is a physicist, he loves to explore this domain, and he basically is testing it using some special instrument, right? Let's say he took a microscope, right? He took a microscope to just basically observe the particles inside this particular container. Let's say this is made up of glass, right? It's see-through. So this particular person is seeing what? This particular person will be seeing atoms, right? And he will be seeing the structure of atoms, okay? Which is basically sort of like this, okay? ठीक है इलेक्ट्रॉन्स उड़ रहे होंगे ठीक है दिस विल बी द न्यूक्लियस ओवर हियर he would see this particular structure ठीक है तो उसके हिसाब से matter is basically defined as the mass is going to be the amount of atom in the body, right? So Kashi is just going to see this particular outside box. He's going to just measure कि हाँ how much liquid is in the container, and depending upon that he's going to find just the he's going to basically measure the amount of mass in the body, right? So relative जो meaning है ना observer की, that is stating that someone can be observing the structure, the matter inside the atom, ठीक है? Or like Ali, which is who is basically using a microscope to observe the structure, वो कितना basically dense है, what amount of matter is inside an atom, right? However, Kashi is just observing the liquid, right? The liquid body. So still they are measuring the amount of mass, right? हमें पता है कि इलेक्ट्रॉन की मास कितनी होती है, right? So इलेक्ट्रॉन की मास होती है 9.11 एक्सपोनेंट -31 kg. दैट्स प्रीटी स्मॉल, ठीक है? एंड काशिफ ने मेजर की, काशिफ ने बोला कि मास ऑफ कंटेनर ए इज 4 किलोग्राम. उसने सिर्फ लिक्विड के मास मेजर कर दिया, राइट? तो सिमिलरली इट्स द सेम थिंग डिपेंडिंग अपॉन ऑब्जर्वर क्या ऑब्जर्व कर रहा है, राइट? डज दैट मेक सेंस दिस पॉइंट? डज दिस पॉइंट ऑफ
सर
ऑब्जर्व?
एक दफा रिपीट करना.
अच्छा.
एक दफा.
अच्छा, ओके, व्हिच पार्ट? वेयर वर यू लॉस्ट?
द ऑब्जर्वर वाली बात जो थी.
Okay, sure. I'm just saying कि Kashif is basically just observing the mass of the liquid in container A, right? And he came to conclusion कि हमारे पास mass of container A is basically with the liquid is 4 kilogram over here. So this particular person Ali is measuring the matter, the mass of one electron of this particular atom of a liquid. ठीक है? They are both doing basically they are both measuring masses. बट एक ओवरऑल स्ट्रक्चर की ओवरऑल बॉडी विद लिक्विड की मास ऑब्जर्व कर रहा है, एक सिंगल एटम के अंदर इलेक्ट्रॉन की मास को ऑब्जर्व कर रहा है, बट दे मतलब दे हैव डिफरेंट पॉइंट ऑफ पर्सपेक्टिव्स, बट दे आर स्टिल मेजरिंग द मास, राइट? सो एटम्स कितना डेंस है उसने मास निकाल ली है, सिमिलरली उसने मास ओवरऑल कंटेनर की निकाल ली है. इट्स जस्ट स्टेटिंग के मास इज जस्ट द अमाउंट ऑफ मैटर इन अ बॉडी, right? The body can be an atom, the body can be container A. Doesn't make sense because this statement is
या इट ओके समझ आ गया.
something which needs to be clear. ठीक है. अच्छा, is it clear to Mashal and Ran also? Give,
Yes.
okay, good.
Yes, sir.
ठीक है. So standard unit of mass, the SI unit of mass is basically you all can see on the slide, that is kilogram, right? We have seen this in the first chapter. कि mass का SI unit is basically kilogram kg, which is written over here. Okay, the confusing part is that we often say, let's say, if I ask, what is your weight, Ran? Ran, what is your weight?
Sir, 35 kg.
35 kg, right? So I said, Ran, आपका weight क्या है? Ran said, my weight of Ryan is 35 kg. So do you think it's the correct logic over here? Are you stating your mass or weight?
My mass.
Right? So that is pretty a big wrong concept which we have been using since decades. Okay. So the term weight is often used when mass is really basically meant over here. Okay. So I was asking about your mass, right? You said कि sir it's 35 kg. ठीक है. Sorry, I was asking about your weight. You said, yes, sir, my weight is 35 kg, but kg is the unit for the mass, right? This is a pretty, which have we have been using this since decades, right? So we need to change about this. So in science, the two ideas are distinct and had different units over here. Okay, weight, we are gonna define weight in next slides over here. So don't confuse this, right? This confusion is not helped by the fact that mass is found on a balance by process, unfortunately called weighing, right? So if you just go to, let's say, a traditional sabzi wala in Karachi or anywhere in Pakistan, okay, so what they do basically, they have a pivot over here, ठीक है, उनके पास एक सेक्शन होता है यहाँ पे, we put the weight, ठीक है, and their section number 2, right? ये मैं थोड़ा गंदा बना दिया, let me just fix it. I guess you go to a sabzi wala, ठीक है, or from the place where you get vegetables, ठीक है. So let's say he put some blocks over here, right? He put some blocks over here, and these blocks has some labels on it, okay? So let's say these are 1 kg blocks, right? Let's say you want to get, let's say mom told you, okay, get me 1 kg of, let's say, onions, okay? So they will put the onions over here. So onions are basically, he keeps the onions on the side of the weighing machine, this weighing, okay? And as soon as they balance out, as soon as they became straight, so he basically takes them out and puts them in a shop, right? So some most of the guys say कि अगर ये weight use कर रहे हैं basically to balance it out, therefore we are getting a weight of 1 kg of onion, right? Again, this is pretty wrong idea, right? We are getting a mass of onions that is equal to 1 kg, right? So the processes which we are using for measuring the mass and the myths which have been established since decades have basically destroyed this idea of mass and weight. So this needs to be clarified in this particular initial chapter, because in the next chapter this will build up, right? So any questions in the idea of mass? Yes or no?
सर तो
What
जब
the?
when we go to जब हम सब्जी वाले के पास जाते हैं तो कभी
What
कभार
I
जो
can
है
hear
वो
you. Sorry,
हम
थोड़ा और से बोला.
सर अब आवाज़ सही आ रही है
अब से आ रही, बेहतर है.
जब हम सब्जी वाले के पास जाते हैं तो अगर हमारे अनियंस जो है वो बिगर साइज में बिग होंगे तो उसका वो कम आएंगे, और अगर जो है छोटे साइज में होंगे तो वो ज़्यादा आएंगे। तो वो इसी वजह से होता है क्योंकि उसके अंदर जो मास है वो डिफरेंट होता है।
Hmm. Yes. So yeah, that's basically, let's imagine if you want to get 1 kg, let's say if you are taking big onions, okay, you get only 4, right? Let's say हर onion की basically एक onion 250 grams, right? So if you combine all of them 4 together, you will get 1 kg mass, right? Imagine if you are taking small onions, obviously they are going to be weighing less, right? So you can get more onions, right? Let's say एक onion is basically approximately 100 grams. We get 10 more onions. And if you combine those mass, you will get 1 kg, right? Okay. Still in the end, we are getting a mass of 1 kilogram of onions, not the weighing. Let's say not, you cannot say कि my onions weight is 1 kilogram. ठीक है, 1 kilo uh, onions is them. ठीक है, so that is a wrong idea over here. So does that make sense? So give me a thumbs up if it makes sense. Everyone, thumbs up if it makes sense. वर्दा समझ नहीं आया? Is वर्दा here? Hello वर्दा. I guess
सर मैंने थम्स अप दे दिया।
I cannot see your thumbs up.
अच्छा।
मुझे लग रहा है वर्दा is just having a cup of coffee. Right?
नहीं नहीं सर, मैं कॉफी नहीं पीती।
अच्छा, चाय चलें, ओके,
नहीं, वो भी नहीं पीती।
पानी पी लूंगी आप, सही है. ठीक है. अच्छा, ओके. सो नाउ दीज आर डेफिनेशंस ऑफ मास. ठीक है, अगर आपके पास इफ यू इन एग्जाम इफ यू गेट अ क्वेश्चन के Ryan, if I ask you a question कि what is mass, right? Usually paper 2 के अंदर आता है. It gives basically comes out for 1 mark, and then they start your theory numerical questions, right? So the mass is the measure of quantity of matter. This is pretty important in an object at rest related to an observer, right? At rest की meaning क्या है कि imagine this is Ali standing over here, ठीक है? And he saw football, right? Football. No, it's not a wheel, it's a football, right? I was a student of Picasso, so I'm pretty good at drawings. So he saw football over here, so it's at rest, ठीक है? तो उसने जाके इसने weigh कर ली इसकी mass and the mass came out to be, let's say, 400 grams, right? So it needs to be at rest because when it starts to move, something complex starts to occur, and which I don't want to state over here because you guys will get confused. Just remember कि ये the mass should be at rest, ठीक है? So what is now we are coming to a new idea, ठीक है? If we have mass, if an object has mass, ठीक है, and you take let's say this object to a planet, ठीक है, which has gravitational field, which has gravity, right? So what happens? It basically has some weight, right? So agar if I ask someone ki what is your weight, so that is not equal to your mass. Okay, let's as Ryan said, we're going to see a formula in a while. Okay, how do you find weight? Okay, so weight, a gravitational force on an object that has mass. Right? So weight is what? It's a gravitational force on an object that has mass. So if any object which has mass, so obviously that would have some certain weight, right? अच्छा जी, so you should know this relation कि 1 kg is equivalent to what? 1000 grams. ठीक है, अगर आपको मास दी भी है, let's say if I give you in a question कि your mass of our object is 250 grams, you will always convert this first of all into kilograms, then solve the question, right? So you can use this relation, ठीक है? So आपके पास this is called ratio method. Let me solve it to you ताकि आपको याद रहे. If convert mass, right? So mass conversion. So from क्या करो? It's basically from grams to kilograms. Grams to kilograms. So we're gonna use a method which is called, which you have already seen in your mathematics class, that is called ratio method, right? So what is the ratio method, Vardha? Can you explain the ratio method?
सर जब हम दोनों को डिवाइड करते हैं
Yes.
like the
One,
two values.
yes. So 1 kilogram is 1000 grams. So let's say if I gave you the mass of one football was 250 grams, convert this into kilograms. So grams के नीचे gonna put grams, ठीक है, and जो unknown है उसके नीचे gonna put just x kg, right? And then you do something which is called magical shake, right? I call it shake. You cross multiply, right? So 1 times 250, sorry ये 260 नहीं है, 250 है. 1 times 250 equals to x times 1000, right? So get x subject over here. So this would be, यहाँ पे 1000 multiply हो रहा है, वहाँ पे आके divide हो जाएगा, right? So x is going to be 250 times 1 is 250 divided by 1000. So your mass in kilograms is 0.25 kg, right? So now similarly, if you want to convert from kilograms to grams, that is pretty simple. तो मुझे बताया कैसे करेंगे? Let's say if I give you now कि let's say Ryan की mass convert into grams, ठीक है? The Ryan's mass is basically 35 kg, right? So what is the question? Convert this to grams. So who will solve it out for me?
Sir, 3,500.
3500, sure.
No, 35,000.
इसके दो तरीके हैं करने के, ठीक है? इसके we have two methods to solve it out. Method one is the prefix method, right? Varta, you can watch the recordings. This is chapter number 1. So what is the prefix method? कि हमने देखा है कि kilo is basically equivalent to, basically state for kilo, it is equivalent to 10 to the power 3, right? So just remove this prefix, so you get your mass in gram, right? So it's going to be simply 35 times exponent 3 grams, that is therefore equivalent to 35,000 grams. Or the second method जो हमने अभी last slide में करा था, we can use that over here, that also works, that is the ratio method. That also works pretty well over here, right? अच्छा जी, ये क्या कहता है? ये कहता है कि simply you should know the relation कि 1 kilogram is 1000 grams. Now you have 35 kg, तो kg के नीचे kg, grams के नीचे gram, so it's unknown, so x आ गया. Then shake, cross multiply. 1 times x equals to 35 times 1000. So it's again, your answer is coming out to be 35,000 grams. Answer. Does that make sense? How do you convert the masses?
Yes. Sir, we can just directly multiply by 1000 as well,
Yeah,
right?
you can do that. You can do that. ठीक है. If you're sure, आपको सही से याद है, you can do that. If you don't trust yourself, then you can use ratio method. ठीक है. It's just a matter of trusting yourself, right? Okay. So हमने ये relation देख लिया है, and then mass measurement, right? So how do you measure mass? ये आपके question आ सकते हैं in your ATP, your alternative to practical exam जो आपका होता है P4, right? So you have P1. एक मिनट. So you have your P1, that is MCQ based, you have your P2, your theory exam, you have your P4, that is your alternative to practical. अच्छा, जो IGCSE कर रहे हैं उनका होगा, उनका बेसिकली हमारा पेपर कोड चेंज होगा. They would have P2, P4 and P6. So it's just the same button, right? One for the MCQs, one for the theory, and one for ATP. That is called alternative to practical. इसमें आप experiments नहीं करेंगे, आप just theory वाले आंसर करके आएंगे, right? Alternative to practical. Can anyone tell me कि how can we measure mass? ठीक है, practical experimentally. I guess you might have seen in your labs कि what instruments do you have. You might have seen some videos online के let's say, अच्छा let's imagine you went to सब्जी वाला, उसको पता है आपको, you know कि they basically use a lever arm, right? एक साइड को बैलेंस करते हैं using a weight, and then to counteract the weight they put this tomatoes or onions, whatever you want, right? Otherwise, what have you seen? What else have you seen which basically measured mass? Have you went to a gold shop? They also measure mass over there, right? Using some instrument. I guess the girls would have went to the gold shops, Varda and Mashal, to buy some earring or some,
Yes.
Yes, sir.
right? You might have seen a glass closed section where they put the stuff and they measure the mass,
Yes, sir.
right? That is pretty
Yes.
similar to this. So now, what else can we use to measure mass in दोनों के अलावा? Can you give me an example where you have seen के this is example where we were measuring mass? Yes. Anyone? तुक्का मारे. Yes. I just want you to guys to participate. ठीक है?
सर डिजिटल स्केल होता है वो जो जिसे हम क्या कहते
Digital
हैं
scale.
सूटकेसेस का
Good.
सूटकेसेस जब हम ट्रैवलिंग करते हैं तो उससे जो हम मेजर करते हैं
एंड एप्लीकेशन बताएं मुझे कहाँ पे इस्तेमाल होते देखा है आपने उसको.
सारे पे इस्तेमाल किया हुआ है हमने घर पे है हमारे पास
ठीक है. गुड. परफेक्ट. राइट. सही है. ठीक है. गुड एग्जाम्पल. सो वी हैव basically we can use several methods to several instruments to basically balance and measure mass. Okay. तो उसमें होता है क्या है हमारे पास. So first of all, let me just skim and then I'm going to draw some annotations and diagrams over here. So there are several kinds of balance used to measure mass. ठीक है. एक तो beam balance है, that is which you see at sabzi wala or any, let's say you fruit shop. ठीक है. Or if you're going to sell your metal and materials, let's say if you're selling your old metal items, right? So they also weigh your metals. ठीक है. Like how much kilograms do you have? ठीक है. In the lever, then you have the lever balance. A system of levers acts against the mass when it is placed in the pen. Okay, and direct reading system is obtained from the position of the scale on the pointer, right? On the lever system. I explained. So we have the first method, okay, and the second method, and the third method to measure mass. That is an electronic balance, right? So it's pretty simple. It's pretty precise. You just put your mass over here. Let's say you have some things over here. Some, let's say we have some gold balls. ठीक है. Let's imagine a parallel world. Gold is supposed to be red. ठीक है. So you can just see the directly your reading over here. So this will give you the reading and you can just directly note it out. So mostly they are found in labs, right? They're found in laboratories over here, ठीक है, in your labs. because they're pretty precise, they have pretty good accuracy, and they can be trusted pretty good. Okay, and they don't occupy much space. They are pretty small and also pretty accurate. Okay, so इस पे मैं बाद में बात करूंगा, उससे पहले आई वांट टू गिव यू एग्जांपल ऑफ instruments, right? What instruments have you used to measure mass? So first of all, they were saying that we have the beam balance, right? The beam balance system. Okay, so what is the system? You might have seen this mostly in Karachi, ठीक है? So यहाँ पे अगर आप आए तो आपको दिखेगा कि एक इंस्ट्रूमेंट होता है sort of this, and it has a base over here. Let's imagine this is the foots, ठीक है? And there is a scale over here, right? This is the pivot over here, and ये होता है scale इसका, ठीक है जी? Drawing a pretty great diagram, ठीक है? This is the over here. अब यहाँ पे you put the weights. Let's say this is a 1 kg block of weight. These are basically 2.5 kg blocks. ठीक है? So overall, आपको basically you're balancing the arm over here. ठीक है? So what is the principle of this? What is the principle of this particular system? The principle is okay, you need to balance. You need to balance the scales, right? So they should be at a certain specific fixed height. This height should be fixed. दोनों की, ठीक है? This reference height. And यहाँ पे you basically put your, let's say you have some materials, let's say you are buying some mangoes, ठीक है? So for mango, I'm going to do this over here, ठीक है? So buying some mangoes, ठीक है? And let me put something green over here. That's a pretty good diagram. Okay. So this basically what happening, yeah, what is happening over here कि अगर आपका यहाँ पे भी basically this is the combined mass of this system is 2 kg, right? And if the combined mass of the mangoes on this right hand side is also 2 kg, then this thing will become almost horizontal, right, over here. And if it has become horizontal, that means के यहाँ पे दोनों की side balance हो गई हैं. That is, this is also 2 kg, this is also 2 kg, right? And therefore you are sure के you are almost at the right amount of mangoes. ठीक है? This is a system which basically measures mass. Again, this takes time. This is pretty inaccurate because humans are basically controlling it. It can basically lead to certain errors also. Okay, let's say if they are not exactly parallel to each other, not exactly straight and horizontal line. Okay, what if the sabzi wala is playing with instruments? ठीक है, imagine उसने नीचे कोई वेट लगा दिया यहाँ पे ऑलरेडी, ठीक है, 0.5 kg का. So it is already going, you're going to already lose 0.5 kg, right? So this can be manipulated, which is can be basically destroyed pretty easily. Okay, it has some, we can say, loopholes, right? And then the third method which we let me just go to the second one, उसके बाद मैं third पे आता हूँ. अच्छा, is this clear? The beam balance, thumbs up. Okay, I guess this is pretty simple, right? Is this clear to everyone else? Yes. Okay, good. Hamza, आप इतनी लेट क्यों आए आज?
सर मैं कहीं गया हुआ था, मैं जैसे ही आया था मैं क्लास में बैठ गया।
ठीक है, सो अगर आपका रिकॉर्डिंग अवेलेबल हो रही है तो आप फायदा उठा रहे हैं, समझा? यू शुड बी इन द क्लास.
सर ऐसा करेगा, ये पीडीएफ मुझे भेज देगा, ये क्या है, पावर पॉइंट की भेज देगा, मैं खुद पढ़ लूंगा।
नहीं, आप खुद क्यों पढ़ेंगे? क्लास में क्यों नहीं आ रहे टाइम पे आप?
मैं गया हुआ था ना, ये भी कह रहा हूँ।
यू शुड हैव टेक्स्टेड मी, ठीक है? ऑलवेज व्हेनेवर यू आर आउटसाइड जस्ट टेक्स्ट मी कि सर मैं इतने मिनट लेट आऊंगा. अब आई वाज वेटिंग फॉर यू फॉर 10 मिनट्स ना, ये हो गया,
सही है।
ठीक है? देन वी हैव अ लेबर बैलेंस सिस्टम ओवर हियर, राइट? द सेकंड वन इज लेबर बैलेंस सिस्टम. लेबर बैलेंस सिस्टम, सो इट्स सिमिलर टू द लास्ट वन. यहाँ पे से डिफरेंस क्या है? डिफरेंस ये है कि लेट मी जस्ट ड्रॉ, लेट मी कॉपी द डायग्राम, not copy this, कुछ बचा ही नहीं है इसका. अच्छा, now let me just redraw this diagram. Let me choose black. Again, you have this system over here. This is your, let's say, the entire system. These are the legs of your, let's say, the lever balance. यहाँ पे you have a pen balance again, the same disc over here, the same lever pivot over here. यहाँ पे you have a meter, right? You have a meter over here, and if the meter needle, see, it has a needle over here. If the needle is at the center, there is no fluctuation, right? If it is at the center, that means that both the sides, both the sides have the same mass, right? Imagine again if I put some blocks over here, and the combined weight of these blocks are 2 kg, right? And again, if I want to buy some mangoes, okay, I'm gonna put the mangoes over here, okay, and I'm gonna put there also their heads over here, okay. Again, if the needle is hitting the center over here, that means ke it is balanced out. If it is at the right side, it means ke right side is overweight, okay. If it is at the left side, it means ke you need to increase the weight at the right hand side, okay. Left side overweight over, okay. This means ke left side is heavy, okay, and this corresponds to right side is heavy, right? So it's just a, we can say, mechanical system to measure the mass side. Okay, I hope it makes sense. Okay, any questions? Does it make sense? Thumbs up, really, thumbs up. Okay, makes sense to Mashal, Bertha, and Hamza, and also Ryan. Hamza, I guess, अभी आए हैं तो वो basically he's trying to make sense के हो क्या रहा है. So we are doing a new chapter, Hamza, that is mass and weight. So we are just learning how to basically measure the mass. Okay, perfect. So
Yes.
let's begin. Hamza was asking a question कि sir last वाले का name क्या है? Last वाले method का name is lever balance system, right? Hamza clear है?
सर कैन यू रिपीट?
यहाँ पे लिखा हुआ है सामने. The lever balance system, right?
इंस्ट्रूमेंट का नाम क्या है ये जो आप इस्तेमाल कर रहे हैं?
This the instrument, the entire thing name is basically the lever balance system. Lever balance बोलते हैं इसको. It's just the body over here.
सही है.
Drawing थोड़ी आपको लग रही होगी थोड़ी 3 dimensional, right? This is the body of the system, and this is the balancing mechanism, right? This is the balancing mechanism. यहाँ पे बैलेंस हो होते हैं सारे लेफ्ट हैंड साइड और राइट हैंड साइड.
समझ गया.
Balancing mechanism, and this entire thing is called the lever system, right? Does that make sense?
यस.
ठीक है, अच्छा जी. So let me just save it out and let's go to the last method of measuring the mass. ये आप practicals exam में in your paper 2 theory exam में पूछ सकते हैं कि which instrument is used to measure mass, right? So you have the beam balance, you have the lever balance, and then you have the electronic balance, right? Electronic top pen balance, that is called the third method, which is basically the electronic or digital top pen balance, right? This is the third method to measure the mass. You just put your mass over here. Let's say again I want to buy mangoes. I just put the mangoes over here. Okay. And let me just put the tail. It seems like carrots. Yeah, but they are mangoes. So what will happen over here? You just power it up. This is the power button over here. Okay. Just power it up. You have some controls buttons over here. We just don't need to explore that. Acha, you directly see you have a digital meter over here. You have a digital meter, and through which on which you can see the direct readings. This will give you direct readings, right? So instead of relying on blocks, okay, relying on weights, okay, these weights, we are just directly electronically balancing, basically measuring the value of the mass. Okay, so that's pretty precise. That is pretty concise also, right? It does not occupy that much space as you see with these instruments, and it just give you it. That's it. Okay. Obviously, since it's an electronic device, it basically has some uncertainty. Okay. So can anyone explain what is meant by uncertainty? किसी
ये
को?
सर हम श्योर नहीं है एग्जैक्ट मैं का
Yeah. So
गेस
basically, that is some error, right? So आपका जो आंसर आएगा, let's say you get a reading of, let's say, the mass of this particular mangoes were 955 grams, right? But they would have certain errors, right? It would be basically, let's say, 953, but वो आपको इंस्ट्रूमेंट के अंदर कुछ एरर है, वो आपको बता रहा है 955, right? But there are some very small margins of error, right? So these are some things which you should keep in mind when you're solving the practical question, right? So ये आपके questions pop up होंगे in your exams. I will also test you guys inshallah practical exam के अंदर. So you get an idea कि how do we think about it, right? So every instrument, even the human, contains error, right? So when you take measurements yourself, ठीक है, तो उसमें भी error आ सकता है. So we will discuss what are those errors, how can those arise, ठीक है, and how do we basically minimize those. Okay, so we have some definition of mass also, right? We have another definition of mass. Okay, some people say okay, mass is it is a measure of it is a measure of inertia of a body, right? Sometimes people also say that. So first of all, can anyone explain what is inertia? अगर किसी पास एग्जांपल है तो एग्जांपल से बता दे किसका inertia ये होता है. What is meant by inertia? वैसे you have the answer in front of you, but just try to give me a guess or whatever you have basically get whatever thoughts you have about inertia. अगर सुना है तो क्या सुना है इसके बारे में? What is inertia of a body? Anyone? A guess maybe?
इनर्शिया कोई फोर्स होती है क्या?
Uh, not a force, but property. It's property of matter. ठीक है. So inertia is property of matter. ठीक है. So what is inertia? The mass of an object is just change from its state of rest or motion. ठीक है. हम पढ़ेंगे कुछ दिनों बाद forces के बारे में, right? We will study about the Newton's laws, right? उसके अंदर we will discuss about the idea of inertia. Let me give you example. Let me give you example. Imagine you're going on a road, ठीक है, and you are standing on a bus. You're standing on a bus and it has some very huge tires, right? Imagine it's a bus, right? It has its gate over here, ठीक है, gate है इसका ये, and it has some windows over here, and you're standing over here, right? Let's say this is Hamza. Hamza is standing over here. Hamza ने बस का एक लेट से पोल पकड़ा हुआ है, just to basically stay consistent. और लेट से Hamza basically खड़ा हुआ है, right? This is basically the window, right? These are the windows over here, and this is the driver. Let's say yes, the window, right? So the bus was traveling at speed of, let's say, 40 meter per second, right? Okay. And the driver sees what? Driver ने एकदम से आगे देखा कि we have a huge jump, right? And what did the driver did? Driver applied the brakes. Okay, and then brakes ने apply कर दिए. And this is all basically smoke over here after applying the brakes. So what will Hamza observe over here? Hamza आपको क्या होगा एकदम से? जैसे जैसे ड्राइवर ने ब्रेक लगाए, ड्राइवर थॉट के आई वांट टू अप्लाई द brakes. What would happen instantly if as soon as the bus driver applies the brakes? What will happen to your body?
सर मुझे सब पता नहीं।
नहीं, अगर आपने बस में ट्रेवल किया है, गाड़ी में ट्रेवल किया है, एकदम से ब्रेक लगते हैं तो व्हाट हैपेंस टू योर बॉडी?
सर आगे जाते झटका लगता है
या ठीक है, यू बेसिकली अंडरगो अ जर्क, राइट? तो होता है क्या, यू बेसिकली हो ये रहा है कि योर दिस इज योर बॉडी, राइट? दिस इज योर बॉडी and your body was also traveling with the bus at a speed of 20 meter per second. As soon as, let's say, this is the bus floor, this is the bus ground, ठीक है, as soon as the let's imagine अब बस की स्पीड क्या हो गई, the bus speed is now 0 मीटर पर सेकेंड, but your body has inertia. अब what is inertia? Let me just tell you the inertia definition over here. So inertia, it is a property of matter which resists change. That is called what? Inertia. So your body still wants to continue at the speed of what? Speed of 20 मीटर पर सेकेंड, लेकिन your bus has stopped. So what happens? You basically undergo a jerk, right? The body wants to continue. So होता ये है कि the body comes over here and you basically undergo a jerk and you basically come back, right? So your body wants to continue at a speed of 20 मीटर पर सेकेंड because inertia is the property which resists change. What was the change? Okay, your change के bus stopped, right? So your body was still wanted to continue at a speed of 20 मीटर पर सेकेंड, but it had to stop. Therefore, you basically you tried to go forward at speed of 20 मीटर पर सेकेंड, but you applied a reverse force. Let's say आपने pole को पकड़ा हुआ था, right? You were holding at a pole, so you basically took the support of a pole to avoid this particular jerk. Does that make sense? What is inertia?
Yes, sir.
Varda, Mashal,
Yes, sir.
ठीक है. These are all real life examples, right? You undergo them every day, ठीक है. So that is why this is the beauty of physics. You can check it out, you can test it out, ठीक है. Okay, so we have approximately 4-5 minutes. So I want to continue and finish these two slides. So we want to start with the idea of weight, ठीक है. अब let me take you to a journey, ठीक है. Let's go to a journey towards. Let me just take you towards out of space. Right? Let's go out of space, ठीक है. And these are the land body marks. We have Earth marks. This is your Mother Earth. This is your, ठीक है, your inspired. This is your moon. ठीक है, and it's orbiting around the sun, around our Earth. ठीक है, like this. Imagine, let's say, one of you. Let's imagine Mashal became an astronaut, right? Now she is in space, right? She is in space with a costume, right? Let me first of all draw her body, and now she's in a costume. Let me just draw the costume, right? She's wearing a costume, and she also is wearing some helmet just to protect herself, right? Okay, so what happens, right? Imagine, I have a question to you guys. What happens when you go into space? Yes, what happens when you go into space?
सर हमारा वेट कम हो जाता है.
वेट कम हो जाएगा. What about Varda?
सर हमारा वेट नहीं कम होता, हमारा मास वो होता है.
हमारा weight will reduce. This is what Hamza says. What about Mashal? So mass will reduce.
Our weight will reduce.
Okay, Varda says basically mass कम हो जाएगी. Similarly, Mashal says कि weight lose हो जाएगा. Okay. Yeah, so basically, these are the ones which have got the right answer. ठीक है. This one's basically, I wanted one of you to say this statement, right? This statement is pretty important, right? And this is sort error and which is sort of a myth in our heads कि हमारी mass कम हो जाती है. Okay, so what happens over here? This is the center of Earth. Let me just call it O. ठीक है. So this is basically trying to basically pull. It was मशाल, right? मशाल को pull करने की कोशिश कर रहा है. So this is the pole gravity है, ठीक है. So it's trying to pull मशाल over here, ठीक है. So यहाँ पे since it's out of Earth over here, but still there will be some gravity, right? So can you imagine कि why still apart being from away from the mother earth, ठीक है? Why are we still attracted towards earth? Can you explain this better? कि हम अर्थ से बाहर आ गए फिर भी हमको ग्रेविटी लगेगी. Is it correct or false? Is it correct or false?
false होगा sir.
False होगा. वर्धा बोली false होगा. Okay. What about everyone else?
Correct.
Correct. Okay. Mashal?
Correct.
Correct. Right. So just imagine हमारा mother earth is rotating around the sun from billion of years, right? It has been rotating around not million, billion of years, ठीक है? Has been created from billion of years. So how is it still together, right? Because sun has a strong pull of gravity, right? It has a pretty strong gravity that is keeping approximately 9 planets. Okay, I don't want to draw every one of them. It is keeping 9 planets in orbit, right? And we have billions of solar systems, and we have millions of galaxies, and we combine all the million of galaxies, we form the universe, right? Okay, so still, if we get, let's say, this Mashal is over here, she would be facing a pull of gravity of Earth also, okay, and some sun also, right? But since she is pretty close to Earth, जो वहाँ पास pull होगा Earth का, that would be pretty strong, right? G of Earth would be strong, and this is G of Sun. तो अभी मैं just to keep it simple, I'm just saying कि if she is pretty close to Earth, तो still gravity लगेगी, right? But gravity would be pretty small, right? So what is the value of gravity which you use in your exam? What is the gravity of Earth?
9.8.
9.8. But in your exam you use 10, right? 10 meter per
Yes.
second square. ठीक है? But उसको round off कर देते हैं. Exactly, to be precise, it is 9.8 meter per second square. ठीक है? So what will happen over here? The gravity at this particular of Mashal, ठीक है? So gravity of Mashal at this particular point will be pretty small than gravity of Earth, which is actually 10 meter per second square, right? And why? Because she has escaped the Earth atmosphere, right? उसने Earth atmosphere को escape कर दिया. She is now into basically boundaries of space. ठीक है? So again, if I want to find the weight, we will see there is a formula. ठीक है? So A times B, there will be a formula through which we can get the weight, and the weight will reduce obviously because हमारी gravity is getting weaker. ठीक है? So as soon as we go away from the land, the gravity force gets weaker. अच्छा, does anyone has experience of going into mountainous regions? Let's say K2 or Kashmir, the northern areas of Pakistan.
Yes, sir.
Yes,
I
sir.
have.
Okay. So वहां पे आपने ऑब्जर्व किया होगा कि एयर की डेंसिटी कम हो जाती है to start.
Yes, sir.
Yes,
Yes,
sir.
right. So and why is that? Because A की डेंसिटी कम इसलिए हो जाती है because now gravity pull पे let's imagine this is a container over here, ठीक है, and this is the earth's land. Imagine if you are on region of K2. Imagine we are at the K2 पहाड़, right? So यहाँ पे जो गैस पार्टिकल्स होंगे इन पे जो ग्रेविटी लग रही है, ठीक है, that would not be exactly 9.8, ठीक है, वो इससे कम होगी थोड़ी. This would be basically 9.6 meter per second square. So now the gas particles become less dense because they can expand easily, right? So if you go to mountainous regions like K2, the boiling point also decreases, right? So boiling point is usually 100 Celsius of water, but at mountainous regions, it basically comes around 97 or 95 Celsius. ठीक है? Why? Because now air is basically less dense, तो वो आराम से boil हो जाता है. Does that make sense? So now you have actually escaped the Earth's basically boundary. You are closer to Earth, but not inside the Earth atmosphere, right? So that is why your weight will reduce. What about the mass? What about the mass? Does अच्छा वर्धा is saying कि mass भी कम हो जाएगी sir. So does anyone has a counterpoint for that कि mass decrease नहीं होगी? क्यों? Can you explain that point?
Sir, because the amount of, uh, we can say the amount of matter in a human body is same. So
Okay.
why would the mass be reduced?
Perfect. Great definition, right? Imagine कि this is Mashal, ठीक है, and she is standing at अर्थ तो वही है राइट, वो अर्थ पर ही है अभी, लेट्स से शी इज इन हर पर्टिकुलर सिटी। एंड इस यहाँ पे जो हमारे पास इसकी मास है मशाल की, दैट इज कमिंग आउट टू बी लेट्स से 40 kg। इमेजिन नाउ शी इज, दिस इज द बाउंड्री ऑफ अर्थ, इमेजिन के बहुत दूर है। नाउ शी इज ओवर हियर राइट। अब इसकी मास अकॉर्डिंग टू वर्दा इज गोइंग टू बी लेस देन 40, लेट्स से 35 over. So is this statement true? Mashal says no. ठीक है, and yes, it is not true. Why? So what is the definition of mass, Varda? What is mass?
Sir, it's the quantity of matter in an object.
Yes, amount of matter in an object, right? Amount of matter, sorry, in an object. सही है। अब आपके पास जो atoms हैं, the number of atoms which combine together in your body to give a mass of 40 kg, would they change when you go to space? Would atoms skip or go out of your body when you go to space?
No.
No, right? So mass always remain. This is pretty important, right? Constant throughout. स्पेलिंग में शॉर्ट फॉर्म निकाल, ठीक है, स्पेलिंग मुझे आती है, समझा? सही है, थ्रू आउट दी यूनिवर्स। ठीक है, whether you go to let's say another universe, you go to a black hole, ठीक है, you go to something else, the mass of an object remains constant। ठीक है, ओनली द वेट वेरीज। हम वेट को भी देखेंगे, विल सी अ फॉर्मूला जिससे वेट डिफाइन होता है, विल कम टू कंक्लूजन कि हाँ इट मेक्स सेंस राइट। ओके, सो लेट मी जस्ट कवर द लास्ट स्लाइड एंड देन वी एंड द सेशन बिकॉज ऑलरेडी ओवर टाइम हो गया है, वी क्लास 6:45 पर है। ओके, सो नाउ लेट्स कंटिन्यू आगे। जस्ट बेसिकली डेफिनेशन ऑफ वेट कंटिन्यूड ओवर हियर। सो अदर एग्जांपल्स क्या है हमारे पास, which basically दे आर सेइंग कि हमारे पास, लेट मी जस्ट स्किम द कंटेंट फर्स्ट ऑफ ऑल, यहाँ पे लिखा हुआ था कि वी ऑल कॉन्स्टेंटली एक्सपीरियंस द फोर्स ऑफ ग्रेविटी, इन अदर वर्ड्स इट्स द पुल ऑफ अर्थ राइट, हाउ स्ट्रॉन्ग द अर्थ इज पुलिंग अस टुवर्ड्स द सेंटर ऑफ द अर्थ राइट, इट कॉजेज an unsupported body to fall down from rest to the ground। ठीक है, imagine if you are standing on the top of a building, ठीक है, एंड लेट्स से दिस इज वर्धा ओवर हियर, वर्धा ने यहाँ से टेनिस की बॉल फेंकी राइट, she threw a tennis ball from the top of a building and it went, obviously पहले रेस्ट पे थी, उसने सिर्फ ड्रॉप कर दी, it will accelerate down the body the building and it will basically hit the ground right, that is the effect of weight, it causes the unsupported body to fall from rest to the ground right। weight is a gravitational force on an object that has mass, again जिसके पास भी mass होगी it will have weight। yes, so it's a gravitational force, it's the pull of gravity। okay, so how do we define weight? Just a small definition is it's just a pull of gravity. It's the pull of gravity of Earth on objects at the surface। ठीक है, so for an object above or on Earth's surface, the nearer it is to the center, the more the Earth attracts it। ठीक है, as I said के हमारे पास सेंटर क्या है Earth का, this is Earth over here, center is over here। ठीक है, if you want to let's say if you want to if you want to let's say find coal or find gold, obviously they are under Earth's crust right, and the more you go downwards the greater the pressure increases right, because gravity force बढ़ती रहती है right, so the closer you are to the center of the earth, तो gravity basically increases right, but normally at the sea level हमारे पास the value होती है हमारे पास gravity that is 9.8 meter per second। so gravity is a force that can act through space, जो मैंने आपको examples दिए अर्थ के सन के, in other words there does not need to be any contact between the two bodies right। so that's the beauty of gravity right। so imagine कि हमारे पास सन is, अगर आपको सनलाइट बेसिकली सनलाइट को पहुंचने के लिए फ्रॉम सन टू अर्थ इट टेक्स अप्रोक्सीमेटली 8 minutes राइट। so imagine कि how is it keeping the entire huge body of earth at a fixed orbit from billion of years, right? So that is the beauty of God also, plus the things which we study, right? So gravity can just needs two bodies of certain masses, and gravity would be there. Okay. Okay. So now similarly, since the gravity does not need any contact between the two bodies, we have also two phenomena which we will discuss in the next chapters. Okay, we have also magnetic force between the magnets, right? इसके बीच में we don't need any contact. Imagine you have a magnet over here. This is the south pole, this is the north pole, and then this is the north pole again, and this is the south pole. So who has played with the magnets in their childhood, or again obviously your child now? कौन खेलता है अभी मैग्नेट से? Ryan plays, Mashal also plays. Who else? Okay, obviously when you bring the north and the north together, they will not they will not come to a contact because the light poles repel each other, right? You don't just see the beauty over here. There is no contact over here. Still without any contact, there is a force. ठीक है, यहाँ पे you will feel the force on your hands. Okay, they are trying to repel each other, right? Similarly, electric forces over here. ठीक है, electric forces में if you get a chance to play with the charges, if you have a positive charge and a positive charge, they would repel each other. Okay, this is positive. They would repel. Again, there is still no contact between the charges and they repel. Right? That is the beauty of creation of the God, right? It contains pretty huge patterns, and we're trying to unwrap few patterns by studying these concepts, right? So when a mass experiences gravitational force, we say कि it is in a gravitational field, right? So similarly, जहाँ पे basically we have magnetic force over here, it basically lies in a magnetic field. ठीक है? तो basically they are saying कि जहाँ जहाँ gravitational force लग रही है, imagine this is Mother Earth over here, and you are standing, let's say over here. This is Hamza standing over here. Hamza को pull हो रहा है gravity के, and he's basically he cannot fly away, right? So the region, the boundaries of the earth under which it is basically attracting all the bodies is called gravitational field. जहाँ जहाँ gravity की force लग रही है, apply हो रही है, that is called gravitational field. Just imagine a football stadium. That's the region where the players can play. That is called a football ground, right? Thus, similarly, जहाँ जहाँ earth can apply the gravitational force, that entire region is called a gravitational field. ठीक है, so weight is the result of gravitational field acting on a mass. अच्छा, weight is a better because you can see कि gravity जहाँ जहाँ object mass खड़ा हुआ है, right? Gravity is always towards center of the earth, right? So it has a direction, that is why it is basically a better quantity. ठीक है, the weight is a better quantity, right? So weight can be equivalent to force because again it is pulling it towards the center of earth, and the SI unit is newtons. ठीक है, so if I want to define the gravitational field, it is a region in which a mass experiences a force due to gravitational attraction, right? That's the region where the Earth can apply the gravitational force, right? So just to summarize, we have studied mass and weight. Let's summarize the details we have studied, right? So now can anyone write tell me definition of mass? What is mass?
Mass of an object is the measure of the amount of matter in it.
Okay, it's the measure of amount of matter in a body, right? And what about weight?
Weight is a gravitational force on object.
Yeah, so it's a pull of gravity, right? And can you explain ke, acha, what is the SI unit of mass? The SI unit in which it is measured, it is kilogram, right? It is kilogram, that is kg. So what about so how is weight measured? The SI unit of weight is basically weight is a force, right? So its SI unit is again Newton. It's Newton, it's capital N. So by Newton, because Newton is covered the three laws of motion, he worked pretty much in the direction of forces. That is why जहाँ जहाँ forces का नाम आएगा वहाँ वहाँ न्यूटन का नाम आएगा, right? And mass is a scalar quantity, right? It has no direction, it has just a magnitude and a unit, right? However, weight हमेशा better quantity है, ठीक है? Imagine कि if I just ask के, like imagine this is a box and you're applying a force, right? applying a force over here, तो force का direction है. Similarly, if I ask you what is the weight of an object, weight is always pointed downwards. ठीक है. So we have also direction of the weight, that is downwards. उसका direction भी आ गया. उसका हमारे पास magnitude भी होता है. Let's say if I say कि weight is 10 newtons, so we have also the magnitude over here. ठीक है. We also have the unit over here, right? We also have the direction, so that is why it is a vector quantity. Okay, so how can you measure mass? By basically using what? How can you measure mass? How can you measure mass? Anyone?
Using a beam balance.
Good. Measured by, first of all, using a beam balance and
लिबर बैलेंस,
electronic balance. Where are the boys? Boys पढ़ नहीं रहे क्या आज?
lever balance,
जबरदस्त. Electronic balance and lever balance. Right? Lever balance. Okay. So the यहाँ पे मैं fourth क्यों आ गया? Should be third over here. Sorry about that. अच्छा, अब we will see कि in the next class इंशाल्लाह कि how do we measure. Okay, let me just give it a time, give it some seconds to breathe. Got stuck. Can anyone tell me a guess कि how would we measure weight?
Sir, using the formula.
नहीं, experimentally बताओ. Experimentally वो तो formula तुम हाँ उसी को formula से will get the weight. But what about experimentally? Do we have something to measure experimentally? To be discussed. Right, so I want you guys to discuss basically and research upon this. So we have an instrument which basically gives you the weight of an object. ठीक है, वो आपके MCQs में भी बहुत दफा आएगा. ठीक है, it's basically, let me give you a hint. Let me give you a hint. It's something dash meter, Newton meter, right? So yeah, let's define first of all the Newton, right? So what is first of all Newton? Imagine Isaac Newton. ठीक है, he was sitting under a tree. The famous story which you have heard from all of your school teachers. ठीक है, and here is Isaac Newton sitting under a tree with huge hairs. ठीक है, an apple falls, right? An apple falls. This is an apple over here. It falls in front of him. So yeah, what would you guys do if you just see a red golden apple falling in front of you? Yes, anyone? What would you do अगर आपके सामने बिल्कुल मतलब
सर मैं खाती हूँ उसको.
yeah, you just say कि wow, you just got a free apple, right? Just let's eat it, right? But obviously wash it out and just grab a bite of it, right? So this particular person, this nerd, did what? ठीक है, and every student basically wished कि he would just eat the apple and just go away, right? So this is, I guess, a story, a point which basically hit his mind why? Why did the apple came down, right? Why did it came down? He hit a thought, why did it came down, right? So he pondered over it, he thought about it, and he discovered basically force, weight, right? And he discovered that every body is attached and attracted towards the center of the earth using some magical thing, right? And he named it a force, right? Since he was the father of finding all the forces and classical physics, which you study in your physics books in your O level, A level courses. So he discovered all of those rules, Newton laws. ठीक है, आप पढ़ेंगी gravitational force law in your A levels, which basically tells you the force between two masses, right? Even let's imagine if you have a pencil in your hand and there is a force between that pencil and your body. ठीक है, न्यूटन says कि every two masses which has masses, every two mass जिसकी mass है, ठीक है, will be attracting each other. But since the mass of pencil is pretty small as compared to you, it does not feel to be you can say visible, right? Now imagine sun and earth, right? Sun has a huge mass. You can fit million of earths onto inside the sun, right? So if you compare Earth and Sun mass, that then the force of gravity between them is pretty strong, right? So that is what Newton by came up with. So let's start to discuss what is Newton, right? So Newton is simply, if you know, okay, it's the SI unit for force, right? We will study this in your chapter of forces. Okay, SI unit of forces. Newton, since he was the pioneer of it, right, he found all of this particular principle represented by capital N, right? So you discover this in 1.5 K. What is the definition is based on a change of speed a force can produce in a body, right? So we'll discuss this in the fifth chapter, right? So weight is a force and therefore should be measured in newtons, as I said, K, and in the last discussion, K, weight is a force, right? Imagine the apple over here, and the apple, let's imagine this is the center of mass, ठीक है? Center of mass क्या होता है? किसी को पता है? What is center of mass of a body?
सर वो जो बॉडी की जो सेंटर पॉइंट होती है जहाँ पूरा मास आई गेस बैलेंस होता है.
Yeah, so it is a point of a body where the entire object's mass appears to it. ठीक है? So we cannot say कि mass is here everywhere at the same time, ना? Because it becomes a very I can say difficult problem to solve. So we for simplicity we assume कि हमारे पास body की एक mass basically comes to a single point that is called, let's say, O, right? And we can say कि weight भी इस point set कर रहा होगा towards the center of earth, right? So for simplicity, we have made some assumptions. So just to simplify and make our thought processes clear and the working to be simple, right? Okay, so the weight of an object is measured by Newton meter, right? So we can just measure it spring balance also, or it is also called Newton meter. Okay, it's same, right? So it is also called Newton meter. Okay, so you can see okay, what happens over here. Can anyone explain this experiment? Okay, how does it measures the force? Let's say if I want to measure the weight of an apple, right? That is how many newtons is the apple weighing, right? So how does the experiment is carried out? Can you explain this? How would I be able to get the mass, or sorry, the weight of this apple?
Sir, can I try?
Yeah, you can try. Sure.
Sir, I think when we are gonna place the apple or an object on the Newton meter, it will show us how much the gravity is pulling that object. So the scale would show us the numbers.
Good. ठीक है. Good. So yeah, that is exactly correct. Imagine इसकी अगर हम mass को assume करें कि इसकी mass is equivalent to 1 kg, right? We explore this in a while. Okay, what is the formula of relation between weight and mass, right? So this you can see over here. This is 0 Newton. Okay, this is 1 Newton. This is 7 Newton, right? So it shows the value reading still 10 Newton, right? Let's imagine it's the instrument which is used to measure till 1 kilogram of mass volume. Okay, so this is the lever over here. You can say this is a supporting lever, right, which moves up and down depending upon the mass value. ठीक है? So let's imagine मैंने apple को hang कर दिया on this supporting lever, and obviously it has some weight, right? It has some weight over here which is acting from the center of the mass vertically downwards, right? This is the weight over here. So what will it do? It will basically extend this spring lever, okay? And it would, let's imagine if it is 1 kg, this would stop approximately here, right? The lever value will be around this value, that is 9.8 newtons, right? So now can anyone explain why is 1 kg equivalent to 9.8 newtons? Can you create a relation between weight and mass? What is the formula of weight which links the mass?
सर वेट का फॉर्मूला है मास इनटू ग्रेविटेशनल फील्ड स्ट्रेंथ.
Yes. ठीक है. So ये हम देखेंगे in this particular slide. So is this clear? How do we measure the weight of an object? Raise your hand if it's clear. Just हाँ, give me a thumbs up. Wow. Clear है, वर्त आपको clear नहीं है. Okay. I am clear. Chale, good. That's good. That's good. So now let's move towards some numerical part, right? So how do you compute things? We can now we know okay, what is weight, what we know what is uh what is mass, right? So now let's try to create some relations, numerical relation between the weight and mass, right? Weight and gravity is का topic का नाम है. So obviously, when there is gravity and when there is mass, this produces some force, right? That is weight. So mass constant होता है. So we are not concerned about mass because mass of any object is constant. So depending upon gravity, the weight changes, right? That is why the topic is named as weight and gravity, right? The weight of the W, that is called W of an object, is the force of gravity. That is pretty important, right? This point is important. Force of gravity acting on it, which gives it an accelerating value g when it is falling freely near the Earth's surface, right? So what is happening over here? Imagine if you are on a top of a building, right? If you are on top of a building, this is your, let's say the windows, and you throw a ball, right? You throw a ball from here, a tennis ball, let's say. So since the ball is falling freely, right? कोई इस पे हम लोग force apply नहीं कर रहे. It's completely falling under gravity, right? Only the force that is acting on it is its weight, and it is falling at an acceleration that is equal to gravity, right? ठीक है जी. So this is called free fall motion, ठीक है? And that can be used to find the equivalent weight of this particular body, right? So if you recall the Newton's second law, do you recall Newton's second law? What was Newton's second law? Anyone? We're going to arrive there at the formula in the next chapter, but just a recall. आप O levels में पढ़ रहे होंगे अभी अपने classes Newton's second law. Anyone? No one. So basically Newton's second law says कि force is equals to mass time acceleration, right? We will discuss this कि कैसे derive होता ये हम देखेंगे. So यहाँ पे force क्या है ball की? This is the ball over here. Ball पे जो force लग रही है, that is the weight, right? And mass of a ball is already it's same, okay? The value of acceleration at which it is falling is gravity, right? Because it is free falling, there is no external force that is acting on it. So we can derive a formula that is called weight equals to mass time gravitational field strength, right? So this is the equivalent, you can say, extend expanded formula, mass times gravity, right? Now is gravity constant for every planet or it changes?
Planet, it
It
changes.
changes.
It changes, right? So gravity of moon is 1.6 meter per second square. Earth की हम लोग 9.8 लेते हैं, but approximately we'll use 10 in our course just to give simpler answers. ठीक है? So this is the weight.
सर
अच्छा, yes,
मेरे स्कूल वालों ने तो कहा है कि वो 9.8 लेंगे.
9.8 लेंगे. Are you sure? We have
जी
used.
आईजीसीएस वो कह रहे थे 9.8
या
लेंगे.
सर आईजीसीएसई के पेपर में लिखा हुआ होता है 9.1 किलोग्राम की एक्सेलरेशन ऑफ फ्री फॉल इज 9.8.
Okay, so if you are IGCSE people, follow 9.81. If you are GC, follow 10, right? So I'm gonna use 10.8, but remember if you can use 10, तो ये भी सही होगा, ठीक है? आपके आंसर बहुत सेम आएंगे, ठीक है? Don't worry. Make sense?
अब वैसे भी मसला नहीं, कैलकुलेटर तो अलाउड होगा ना हर पेपर में.
So it's just a difference of 0.02. Yeah. Okay, so this is, अच्छा, if I talk about the SI units, ठीक है? तो इसके SI units में बच्चे कंफ्यूज होते हैं, वो देख लेते हैं हम लोग क्या होते हैं हमारे पास. The SI units of weight. The SI units, ठीक है? तो there are two now of particular quantity that is called weight. अच्छा जी, so हमें पता है first of all the first assignment which you know कि weight is equals to, let me just use the terms, ठीक है? Not the entire definition or names over here. We know कि weight equals to mg, right? And since it's a force, it is equivalent to force, ठीक है? और force of gravity है. So this is simply force का हमें assignment पता है, it's Newton. So we can just say कि weight का assignment is, one of the assignment is Newton, right? Newton n. The second representation is can be as follows, right? So weight is equals to mg. Let me solve the right hand side, ठीक है? मैं right hand side को expand कर रहा हूँ using their SI units, ठीक है? Mass times gravity, ठीक है? Gravity क्या है? Acceleration, right? Acceleration due to earth. The acceleration due to earth. Due to earth. Earth's gravity. Right? So mass का SI unit क्या होता है? It's kilogram. And what is the SI unit of acceleration? We have seen that in our last chapter, motion में acceleration is change in velocity upon time. So the SI unit of acceleration is meter per second squared. Does that make sense?
Yes,
Hello.
sir.
ठीक है, so it's going to be kilogram meter per second square. So we can also represent the SI unit of weight as kilogram meter per second square. ठीक है, समझ आया आप लोगों को कैसे आया?
जी सर.
ठीक है, so usually it will be Newton, but if they let's say somehow ask you कि is there any other representation of the weight SI unit, ठीक है, of Newton, so you can just use this formula. Right? I hope it makes sense. Raise your hand. Give me a thumbs up. हम लोग समझ आ गया, रैंक को समझ आ गया. What about वर्दा and मशाल? मशाल clear है. Good. ठीक है. So now let's go back and see did we miss something. So yeah, usually we had the accurate value is basically it is 9.81 by the way. ठीक है, आप A levels में you will use 9.81 meter per second square, but in your O levels case जैसे कि we have 9.81. So if we have a mass of 1 kg, we have a weight of 9.8 जो हमने यहाँ पे देखा था, right? So if I now apply the formula, weight equals to mg, and if I take gravity as what, 9.8 meter per second square, so what will happen? It would be weight equals to, and if I given ki mass is also 1 kilogram, okay, so it's 1 times 9.8. So therefore the apple weight is coming out to be 9.8 Newton theoretically. So experimentally you will see कि यहाँ पे इसका reading आ रही होगी यहाँ पे, ठीक. Okay, so yeah, so you can say कि it's near enough 10 Newton, right? So again they are saying कि if you have a mass of 2 kg, it would be 20 Newton. So they are simply telling you कि what is the relation between weight and mass, right? So weight equals to mass times gravity. If I try to find the relation between weight and mass, it's directly proportional, right? So weight is directly proportional to mass. Does that make sense? Because हमारा gravity constant है ना on Earth, that is approximately equals to 10 meter per second square. ठीक है, so if I plot the graph of this, if I have two quantities which are directly proportional, if you recall your basic mathematics class, so we have a graph of this, right? That says K weight is directly proportional to mass. ठीक है, if you just see this graph, if I increase the mass, the weight also increases proportionally. Does that make sense? How do we plot the graph of a direct proportional quantity? Okay, good. और मशालू clear है, अरयान clear है, हमजा and वर्दा are left. वर्दा clear है, हमजा clear है, नहीं समझ आया. Okay, good, good. ठीक है, so just giving you some mathematical tools to analyze. ठीक है, you should have all the skills, right? You should be able to use formulas to analyze your quantity. You should be able to use graphical methods to analyze the property, right? Anything which you want to analyze, right? ठीक है, so gravitational field हम देख लेते हैं कि what is this, right? So again, as we have discussed before, okay, we have Mother Earth, right? This is our Mother Earth over here. This is the center of Earth. Oh, okay. So under this region, we have gravity, right? It is pulling everything in this region, okay? So this is basically gravity, and this entire thing, this entire region is called what? Under which the Earth can apply gravitational force. That is called gravitational field, right? Okay, so the force of gravity acts through the space and can cause an object, but not in contact with the Earth to fall to the ground. As I told you example before also, the last class, even if you are at space, but you are near to the Earth, okay, your Earth will be pulling you towards yourself. Okay, so gravity is a force that acts without any contact, right? So even if you are far outside the Earth's boundary, still there will be a force of gravity that will try to attract you, right? But it will be pretty small as compared to on surface, right? अगर 10 है भी तो वहां पे it could be around 3 4, right? ठीक है, so we try to explain its existence by saying that the Earth is surrounded by a gravitational field which exerts a force on any object in the field, right? So imagine कि this is the field. Even if you are on the, let's say, in an aeroplane over here, let's say you are over here, right? In an airplane, right? So यहाँ पे भी there would be a force of gravity acting. Still, but you are not in contact with the Earth. You're just sitting in a plane which is again flying in the air, which is also not having any contact with the ground. Still, it is going to attract you, right? Gravitational field strength is defined as the force acting per unit mass. We will describe this ये कैसे हो रहा है, ठीक है? So, is gravitational field strength is a vector quantity or a scalar quantity?
Vector.
Because as I draw the diagram over here, you can see from here, okay, it has all arrows shown over here, right? So gravitational field strength has a point, right? It has a direction, okay, where is the gravity attracting everything towards the center of the earth, right? अच्छा, in your astronomy and cosmology chapter, we will discuss कि अगर gravity बहुत ज़्यादा strong हो जाए, right? जब ऐसा सिनेरियो आते हैं कि मैंने स्टार बेसिकली कूल्स ऑफ ना, लेट्स से सन की हमारी लाइफ इज मिलियन ऑफ ईयर्स, राइट? So let's say there is a time at which the sun's fuel, that is helium, right, that is fusing. तो वहाँ पे sun पे we are causing fusion. वहाँ पे fusion हो रहा है, उससे basically हाइड्रोजन एटम are combining together. ठीक है? We have hydrogen atom combining together to form basically an helium atom, right? 4 2. ठीक है? So deuterium and tritium, deuterium and tritium. Yeah. तो यहाँ पे हाइड्रोजन के आइसोटोप्स मिलके ना हीलियम एटम बना रहे हैं, ठीक है? सो फ्यूजन हो रहा है यहाँ पे. So this basically hydrogen is a fuel, right? Hydrogen atoms are again not in abundance; they are in a lack of amount. So yeah, they are not going to last forever, right? So sun की भी देगा lifetime, okay, but it is million of years, so don't worry. So this is the reason कि अच्छा अब when a star like sun cools off, ठीक है? So there is some property, there is some rule. Okay? If the gravity is pretty strong, if it gets pretty strong, it can basically crush the entire sun into a single point. ठीक है? And after that it becomes a black hole. ठीक है? Or a wormhole. ठीक है? You will study this in your chapter, in your cosmology chapter, कि how does this happen, ठीक है? And what is the life of a star? How does a star is born? ठीक है? And how is a black hole born? ठीक है? And when does it die? Even black holes die off, ठीक है? Everything dies off, ठीक है? That is composed of matter. Everything has an ending point. ठीक है? So its direction is same as a gravitational force. That is why it is a vector quantity. It has direction and magnitude and SI unit, right? ठीक है? So this is basically this is representing G जो हम लिखते हैं फॉर्मूला के अंदर. This is your gravitational field strength in your formula weight. Gravitational field strength. Basically the acceleration of gravity, right? So let's derive why do we have these two units over here, right? So we'll be using 9.8 for the course just to stay consistent, right? So we have two units shown over here, right? Newton per kg and meter per second square. So why is it the case? Okay, so let's analyze it. So let's analyze why is it Newton per kilogram. So we have the formula weight that says weight is equals to mass times gravity, right? If I try to make gravitational field strength, इसमें basically what is W? W is the weight.
जी.
Okay, ठीक है. So let's begin. So I was just saying the terms के weight is basically W is weight over here, M is equivalent to the mass of an object, right? And the G is your gravitational field strength, right? It is your gravitational field strength. So we are going to derive the SI unit for this particular quantity, right? G. Okay, so let me insert a blank slide. So let's manipulate the formula, right? So we have weight equals to mg. Let's make g subject, right? So we're going to get weight upon mass, right? If you recall, what is the SI unit of weight, which we have seen? It is Newton, right? And what is the SI unit of mass? It's kilogram. Therefore, we have one of the possibility of SI units of gravitational field strength as it is Newton per kg. Does that make sense?
Yes, sir.
Okay. सबको समझ आया? Give me a thumbs up जल्दी. Okay, Ayan को clear है, Mashal को clear है, Hamza को clear है already. And what about Vardha? Yeah, it's clear. That's good. Okay. So now let's see why is it meter per second square, right? Why is it meter per second square? why is it meter per second square? So again, imagine what was the point from where we derived the weight equals to mg formula, right? We derived the formula from certain thing, right? What was that? What was the rule which we,
F equals to ma.
yeah, we used this formula, which was a Newton's second law, that is F equals to m, right? So इसके अंदर what are we comparing, right? We compared कि A is same as the G right over here, which is acceleration. Let me just fix my T. It's not good. Acceleration, right? So imagine why is it same? So as I told you before, अभी भी बता देते हैं आपको हम. Okay, imagine you are in a hot air balloon, right? And you love doing bungee jumping. Right? These are the supporting pillars, and you have the balloon, right? And you do bungee jumping. You have this particular rope, and you are basically feeling the gravitational field stream, right? So what happens? You are free falling, right? It is free falling. You are not. You're basically completely falling under gravity only. There is no external forcing. There is no external force जो आपको push कर रही है या pull कर रही है. It's completely if you are accelerating freely in the atmosphere, so your acceleration value will be equals to gravitational field strength. Right? So imagine what is the SI unit of acceleration? It is meters per second square, right? So since value of gravity is constant, that is 9.8 meter per second square. So you can imagine you are falling under an acceleration, constant acceleration of value of 9.8 meter per second square. Okay, so that is stating if you have a gravitational field acting on your body and you are doing in free fall motion, so acceleration of your body will be 9.8 meter per second square. We can also derive this. We can also derive this from this formula. Okay, acceleration is basically equivalent to g. Okay, and what is the SI unit of acceleration? That is again meter per second square. And therefore, we can just use this representation also to represent your gravitational field strength as such. Okay, does that make sense?
Yes, sir.
Okay, okay. If you have a question, please you can raise the hand and ask. And in the next slide, there is some analysis of the situation which we discussed. Okay, we have two ways regarding G. Okay, when considering objects falling freely, we can think of it an acceleration of 9.8 meter per second square. That has been discussed in the last slide. When an object of known mass is at rest and we wish to know the force of gravity acting on it, so we can think G as the Earth's gravitational field strength of 9.8. Okay, imagine अगर आपने, let's say you have a box over here, right? And it is basically at rest. So what is the gravitational field strength that is causing it to basically be still at this particular position? Okay, you can define this as it is gravitational field strength is basically applying near 9.8 meter per kg to basically keep this body at this position at a particular instant of time. Okay. So the gravitational field strength is equivalent to acceleration of free fall, which we have seen. So the weight of an object is directly proportional to its mass. जो हमने भी देखा है, ठीक है? We explain why G is same for all objects. तो ये पॉइंट हम देखते हैं भी ये क्या बोलना चाह रहा है. It's basically saying it's stating the following thing. If I draw the graph, okay, this is mass over here, this is the weight. And if I'm just saying this is the formula, right? Weight equals to mg. अच्छा हमारे पास क्या है, हमारे पास g is constant, right? अर्थ की constant होती है, that is 9.8 meter per second square. Now I want to create a relation between weight and mass, and then we came to conclusion that weight is directly proportional to mass, right? Because keeping that in mind, g is constant. So we can see that there would be this particular relation, right? It's a straight line. And if you recall in basic mathematics class, the slope of a straight line is what? Is something.
Acceleration.
Is
Acceleration.
नहीं, स्लोप ऑफ अ स्ट्रेट लाइन, अगर आपके पास कोई स्ट्रेट लाइन हो उसका आप स्लोप निकालें यूजिंग एनी 2 पॉइंट्स, लेट्स से पॉइंट ए पॉइंट बी, will it be constant or varying? Let's say
कांस्टेंट।
Constant.
if you have multiple points, if you take point A, C, if you take point C, B, if you take point A, B, you get the same value of M. ठीक है, that is constant. So अभी आप if you find the slope of this particular graph using any 2 points, ठीक है, let's say आपने ये change in y ले लिया और आपने ये पूरा change in y ले लिया, ठीक है, और आपने if you use this change in x, if you using change in x, so you will end up with the same value, that is going to be change in weight upon change in mass, that is going to be constant, right? That states the reason, that is the relation between weight and mass, right? Gravity on a single planet is going to be constant, so weight over mass ratio is going to be constant throughout any single planet, right? That is why gravity is constant. ठीक है, thus we can say gravity is constant in a single particular planet, right?
सर ग्रेविटी से रिलेटेड ग्राफ्स हमेशा कांस्टेंट होंगे?
नहीं, मतलब वेट, अगर आप ये रिलेशन देखें ना, रिलेशन देखें हमने कैसा बनाया, वी यूज दिस इक्वेशन, राइट? सिंस वी वांट टू से ना कि हमारे पास व्हाट इज द रिलेशन कमिंग आउट कि वेट इज डायरेक्टली प्रोपोर्शनल टू मास, हमने इसको प्लॉट करा, राइट? हियर, एंड दिस रिलेशन सेइंग कि इट्स अ स्ट्रेट लाइन, इफ आई ट्राई टू फाइंड द स्लोप ऑफ द स्ट्रेट लाइन, it comes out to be constant, right? Because the straight line. So gravity constant है, we can support this by using this experiment, right? So you can change mass, you can use different masses. Let's say आपके पास ब्लॉक्स हैं, right? आपके पास 1 kg का ब्लॉक है, आपके पास 2 kg का ब्लॉक है, आप उसकी ना वेट को ना वे करें यूजिंग न्यूटन मीटर, then you can plot this graph, right? You can plot this graph and it will come out to be exactly this particular trend. So you can say कि हमारे पास जो वैल्यू आ रही है ग्रेविटी की on earth would be pretty closely to 9.8 meter per second. ठीक है, you can verify this experimentally too. This can be a homework if you want, if you have a let's say weighing machine, can use different object or different masses, तो आप उसको प्लॉट करें, चेक करें क्या हो रहा है. Does that make sense? Yes or no?
यस।
ठीक है, या so अच्छा, we discussed, we confirmed कि mass of an object is always constant but the weight varies, right? Because it depends upon the value of gravity. ठीक है, on the moon it is 1.6 meter per second square. So the mass of 1 kg has a weight of 1.6 Newton. ठीक है. So now what is it saying is as follows. Let me just insert a blank slide. ठीक है. So it is stating the following, right? Imagine if we are talking about on Earth, right? This is on Earth. And this section is on basically on moon, right? Let's imagine if Hamza goes to the moon, right? Hamza ki let's say mass is around 55 kg. ठीक है. Mass would be same, right, on every part of the universe. So उसकी mass भी यहाँ पे same रहेगी. I know the value of gravity on Earth, that is 9.8 meter per second square. I know the value of gravity, sorry, the gravitational field and the moon also, that is 1.6 meter per second square, right? I wish to find the weight of Hamza on Earth, right? कितना है? Similarly, I want to find weight of Hamza on moon. ठीक है, कितना आएगा? So I can just apply the formula. I know what is the formula of weight and mass, that is mg, right? So let's apply the formulas. So weight of Hamza on Earth is going to be 55 times 9.8. And similarly, weight of Hamza on moon will be 55 times 1.6 meter per second square. The weight of Hamza on Earth is coming out to be these many newtons. The weight of Hamza is coming out to be these many newtons on the moon. Right. So let's do this. So 55 times 9.8 is coming out to be 539 newtons. And the weight of the moon is coming out to be just 88 newtons. Imagine if you want to lose weight, right? Simply go to the moon, right? So imagine there's a huge difference. There's a huge difference. अच्छा, कुछ इश्यूज भी होते हैं, राइट? इफ यू गो टू अ प्लेस जहाँ पे ग्रेविटी की फोर्स बहुत वीक है, So आपके organs, आपकी body becomes unstable, right? Because your heart, your lungs, your kidneys, everything inside your body is designed to be basically at a particular gravity value of 9.8, right? If you go to a moon of gravity 1.6 meter per second square, your inside body basically organs start to expand, right? Because उन पर कम force लग रही है. What is also gravity? Gravity is Newton per kg, right? It's force per kilogram also. So your organs start to expand. That is why they have special designed astro basically space suits, which counteracts this particular effect, right? So this is just the end of the chapter. I hope it makes sense. So any questions till now? Hello.
सर ऑर्गन्स एक्सपैंड कैसे होता है, मतलब समझ नहीं आ रहा.
हाँ, तो imagine कि this is your heart, right? And this is your heart, right? In on Earth, right? Let's imagine this is on Earth. And उस पे जो gravity force लग रही है, ठीक है? That is 9.8 Newton per kg, right? If you go to the moon now, what happens? The same heart of your body, right? Experiences now a decreased gravitational force of 1.6 Newton per kg. तो एयर प्रेशर बेसिकली डिफरेंस से हमारे पास ऑर्गन्स विल स्टार्ट टू एक्सपैंड और दे आर डिजाइन टू बेसिकली एक्सपीरियंस दिस मच फोर्स, राइट? बट सिंस अब आउटसाइड फोर्स जो बेसिकली इसको दैट इज कीपिंग इट डाउन, दैट इज फोर्सिंग इट डाउन टू स्टे एट दिस पर्टिकुलर पोजीशन, this has decreased by way huge amount. So the organs also start to expand, right? There is also a movie on this particular topic. So there was a person, there was a first child that was born on Mars. So then he came onto Earth back to his parents, right? So his body starts to act abnormally because Mars gravity is around 6.4, right? Earth base 9.8. So जब increase भी होती है तो भी issue होता है.